I'll begin today by briefly telling you a bit about our history and how the research network evolved and what our goals for it are. So WECAN owns and operates 5 2-megawatt wind turbines, which were commissioned in spring of 2013. And we recently installed a 109 kilowatt Jinko PV array, as well as a 111.5 kilowatt, 223 kilowatt hour Tesla battery. We also have a well-instrumented IEC compliant 80-meter Met mast on our site. Our wind R&D park is open to other institutes, academia, and industry to be used as a test laboratory. Our mission at WECAN is to advance the development of wind energy across Canada through research, testing, innovation, and collaboration. As a national research facility and independent wind farm operator with strong industry ties, we feel we're well positioned to lead research in the advancement of wind energy. We feel that for wind energy to advance in Canada, there's a need for industry, utilities, system operators, and academia to collaborate. Because academics have a specialized expertise to work with data from industry, this can be seen to be difficult due to proprietary issues, but we find that as long as there's mutual benefit, all of these agreements can be worked through and collaborations are possible. At WECAN, we have 2 major streams of research, asset management or service life estimation and grid integration. And you'll be seeing presentations on each of these topics throughout this webinar series. I started working at WECAN around the time that the Wind Energy Strategic Network, or WESNet, was wrapping up in 2014. And there really hasn't been anything similar in this area since. So for the last 7 years, there's been a group of us talking about how great it would be to have a Canadian wind energy research network. Our goal for this network is to create a forum for collaboration and to accelerate the acceptance and the impacts of research projects. The plan is that we would hold at least 1 meeting per year where members could share their current and planned research activities and research needs. And then members who have intersecting areas of research are encouraged to engage in joint research and to pursue external funding opportunities. Currently, the research network focuses on megawatt scale wind turbine generators, but if there's interest, we could expand into other areas such as solar and storage applications. I'd like to thank the steering committee who helped me put this network together, Ryan Kilpatrick from NRCan, Brooke Caravo and Lindsay Miller from the University of Windsor, Cedric Arbez from Nergica, and Eldridge Rebello and Scott Harper from WECAN. I'd also like to thank our WECAN interns, Jeremy Cadence and Tim Jordan, who have been helping out with the logistics of this webinar series. This first research network meeting is a series of 60 to 90-minute webinars with short 5-minute presentations followed by a brief discussion. We on the steering committee agreed on this format because we wanted to get as many people involved as we could, but wanted it to be palatable and not overwhelming. We hope it works well, but if you have any comments or suggestions, please let me or any of the steering committee know. We hope this format will allow us to get an idea of the type of wind energy research that is taking place across Canada and to begin to form collaborations. After the webinars, the steering committee will summarize the results and present them to industry and government. And then we'll invite you all to a follow-up meeting in a few months, along with interested personnel from industry and funding agencies to talk about next steps for the research network. We have a great group of speakers today. First, we'll have Jen Hiscock from NRCan. She'll describe NRCan's goals for the research network. Then Lushen Chang from UNB will tell us about WESNet. And then finally, Phil McKay from CanRIA will give an industry's perspective on wind energy research. On Wednesday, we'll meet at the same time to talk about IEA wind tasks, wind turbine LES, wind turbine aerodynamics, and wind farm modeling. On Friday, we'll talk about grid integration and asset management, focusing on blades. Next Monday, we'll talk about asset management. Next Wednesday, we'll talk about cold climate and climate change. And then on Tuesday, April 6th, we'll talk about forecasting and offshore wind. So now I'll invite Jen Hiscock from NRCan to, I'll stop sharing my slide. I'll invite Jen Hiscock to start sharing her slides as well. And thank you, Jen, for agreeing to present at this meeting.
Yeah, thanks very much. Oh, sorry.
No, I just wanted to give you a proper, you're the Deputy Director, Smart Grid and Renewable Energy Portfolio. So we'll hear about NRCan's perspective on the research network.
Yeah, thanks very much, Marianne. So I didn't actually prepare slides today, so I'll do my best to communicate things coherently, and I don't think I'm going to need a full 10 minutes, which should be good for other parts of your program where folks are going to need to interact. But I wanted to at least be able to communicate our enthusiasm for seeing this research network launch. And as you mentioned, Marianne, we haven't had this sort of coordinated conversation or cohesive conversation, just focused on the research needs since 2014. So at the same time, the Office of Energy R&D within NRCan has undergone a number of changes in the program management elements. So we used to bring together experts as well into these working groups that would advise us on the R&D priorities into the coming years. But as we've moved from the governance structure of the old programming that we had to the new programming, some of those things ended, and as we were growing, we haven't necessarily established those sort of ongoing interactions with industry on detailing the research priorities that we see for Canada and the energy space. So we're doing some work right now behind well, at least on our end, it's not yet become open to stakeholder input, but it's trying to start to identify what we're calling innovation system objectives for the various energy sectors that we're active in. And I would say, to preface that, one could argue that the Office of Energy R&D has been, since its inception in the 70s, really focused on whole systems transformation. But I would say that along the way, there was a lot of emphasis just put on advancing technologies through some kind of S-curve of a technology development cycle on various graphs and charts that you've probably seen before from us, or we look at the early curiosity driven to applied R&D to demonstration to pre-commercialization and so on, as just looking at this linear pathway for successful technologies to progress from concept to market. I would say that with the government's current goal of being able to reach net zero emissions by 2050 for Canada's economy, there's a real focus on understanding energy sector transformation and the role that our investments in energy innovation are going to play in the pathway discovery to realizing that. So we're not just interested in developing technologies, we're interested in supporting the whole energy systems transformation that we think needs to happen to be able to realize those net zero by 2050 goals, and recognizing that sometimes those adoption pathways that are going to be required later on need to be considered earlier on in the technology development cycle. So while in the past we may have gotten away with thinking about those things once we're at the commercialization stage, how do we need to interact with regulators, with financiers, with lenders, with the potential owners and operators of these technologies, now that we're at that stage to consider it. I mean, I think in a lot of ways I'm probably preaching to the choir here because you've been quite conscious of these things, but I think we haven't necessarily factored that into the way that we design and deliver our programs connecting that later stage adoption, learning and insight into the earlier stage R&D efforts, because that pathway focus is going to be connective across those different stages of technology development. So in a lot of the way that I'm presenting the work that we're doing in the electricity space and in renewables and in the smart grid space is looking not only at developing technologies, but really increasingly developing systems that these technologies are going to get integrated into. And by that, I mean more of the infrastructure and the physical systems, which are now equally hardware as they are cyber. And then from that, looking into that pathway discovery, which includes all of the actors in sort of the soft system, the institutions that surround them. And for electricity, of course, this is very much a regulated sector that we're talking about integrating these technologies into. And so that means that there's a lot of work that needs to be done in the years leading up to these technologies being integrated. And a number of the players in this group today have been hard at work at supporting that sort of later stage adoption and integration work, which I really appreciate. So what I'd like to do is incorporate a little bit better continuity between the work that we fund on the demonstration side, and we're working with the parts of NRCan that are also doing deployment funding to try to connect the results and the insight that we're learning from there back to the research conversation and vice versa. So it's really helpful for us to have a group like this, like the Wind Energy Research Network, to be able to interact with and validate and test some of what we think we're seeing at the program level across projects. And we'll be continuing to develop our work on the innovation system objectives. And so I'd like to be able to bring it to a community like this to validate some of where we think that we're going on this. And also take advantage of the opportunity that you plan annually to be able to bring this research together in one space and have a conversation about it across the players in the space, and just benefit from that conversation generally. So thank you so much for doing the legwork we can on assembling this group. It is so much easier for us to be able to interact with a community that's already connected and already looking to produce things together. And so I very much look forward to partnering with you at an organizational, and to the degree that we can put things out in the public commentary on things that we're seeing on the ground, and just putting that evidence out there to inform the public discourse. I'd be very interested to hear about how we might be able to connect things on that level. So I don't want to detract from the very technical conversations that need to happen and that I'm sure you will have happen. And please do continue to keep it at that level. But I'm also looking forward to being able to distill out the higher level policy messages that we'd like to make more accessible to governments at all levels as it pertains to the development of these renewable technologies that we can now rely on for our firm, flexible grids of the future. So I think that's hopefully sort of covered the gamut and given you a sense of why I'm so excited to see this group launch and looking forward to the conversations that you have.
Thank you so much, Jen. That was great. It's great to hear your perspective, and I think it's good insight for all of us to have as the Wind Energy Research Network. Now I'm going to ask Lushen Chang from UNB and the former director of the Wind Energy Strategic Network to get ready to present. I see you're sharing your screen. I hope that we'll have time for questions after this talk. So if you do have any questions, you can ask them then, or you can enter them in the chat. Thank you, Lushen.
Thank you. Thank you, Marianne. I am certainly excited to do this presentation. It's been quite a while. I even saw a few Westnet researchers on this forum. It's good to see everybody. My name is Liu Chen Chan with the University of New Brunswick. The NSERC Wind Energy Strategic Network. That was the first Canada-wide research network, strong partnerships of 39 researchers from 16 universities funded by NSERC and also 13 partners. So today I will provide a brief overview of Westnet. To start with, it was initiated actually back in 2004. That's quite a few years ahead of its time. During that period of time, the wind industry experienced significant growth very fast, much faster than what it is now. And the technologies were evolving, and there were not as many as young engineers now involved in wind energy. So there was a need for technology. There was need for young engineers for the next generation workforce. So I don't remember you can recall or not. That would be back in 2004 at NRCan's meetings talking about consultation about renewable energy. I believe it's poll 5.2, something like that. There was a consensus reached during that period of time that we need a large-scaled research network focusing on the Canadian needs for wind technologies, and the things were evolving. I believe in 2006, WECAN was formed out of AWTS. That's in that time frame. So the formal process started in 2004 to establish the Canadian Wind Energy Strategic Network under the NSERC Strategic Network Program. During that time, NRCan, Canvia, WECAN, and the Techno Center now is Nordica, and quite a few utilities were all involved in supporting the network. We filed the application in April 2007. Then there was a site visit evaluation, there was approval process at NSERC. So at the end of 2007, the funding was approved from NSERC by contributing $5 million to the network, plus the partners and the university's contribution of $2 million. So altogether, it's about $7 million for 5 years of the Westnet mandate. So this is the first Canada-wide network with 39 university researchers. Indeed, the research organizations, the researchers, and the funding partners were across the country from pretty much all provinces except for Alberta. You can see lots of organizations from Quebec, Ontario, and Atlantic region were quite keen in supporting Westnet activities. The structure of organization look like this board of directors, and then the scientific committee, the outreach committee, and for themes, I'm just going to talk about a little bit on these research programs. You can see lots of familiar faces. Carl Brothers was the chair of the board, and you have Scott Harper, Frederick Colche, Tom Levy. There are a few of them, plus my colleagues at the universities, Yves Liang, Christina Song, Reza Irvani, Giza Hus, Nat Jalali. Of course, we were very energetic at that time. a lot younger than what it is now. This was one of the board meetings held at weekend. You can recognize the boardroom was just the new building. Very exciting period of time. The projects were defined in the early stage. So the NSERC strategic network program would work like this. You have a research program defined, people defined, partners defined, and then you work according to your research plan. And that is good in defining the research program. However, it did not provide a mechanism to evolve during the period of that 5-6 years. So we have looked into the needs at that time for research and also the interests of the researchers. There were 4 themes pretty much covering most of the innovation chains areas in the wind area: the resources assessment, the extraction, that would be the wind farm aerodynamics, and the turbine dynamics, the integration into the power systems, plus the economic optimization. So these 4 themes typically defined the research programs and research projects. The first theme is on wind resources assessment and the wind forecast. It ranges from all the way from the hardware anemometers to wind atlas to wind forecast. I recognize Andre and Jean Joel. Hello, you can recognize that's your ice-free anemometer. And theme 2 was mostly focusing on wind energy extraction, the wind turbine aerodynamics, the wind farm dynamics modeling. It is during that period of time that the wind dome in Western Ontario was initialized, separated from Westland, that is funded by CFI, but nonetheless, the researchers were heavily involved in that program too. On the theme 3, that's on integration from wind conversion system to the grid, power converters, the control systems, and storage, both at the large scale and the small scale at the distributed generation level. Theme 4 was about the modeling of the entire energy system, optimization of wind energy in the context of the power market, the electricity market, and the energy systems. All in all, people were working hard for the research projects. There were glitches. There are so many projects. I remember some projects did have difficulties in getting the students to start the research. As a result, some projects were delayed, but the network researchers were adaptive, quick enough to ramp up the research projects. So I here highlighted a few of them, including the ice-free anemometer. I think that project led to commercialization, and Andre, you've started your position at the university after you finished the project. But nonetheless, we did have a few projects which led into demonstration and commercialization. The wind forecast tool now still being used by some utilities and continued in their technical track. The composite material, the lightweight wind towers for small turbines using composite materials, the anti-icing technologies from the anti-icing materials lab. And those projects have significant outcomes out of the research programs. And we were able to integrate the blade design, control design, power converters, generators into one full-scale small wind turbine. That's a 10 kilowatt system demonstrated at WECAN, integrating the results of quite a few WestNet projects. But by far, I think the highlight would have to be the young professionals, our next generation wind engineers, through the training programs, the research programs, the summer schools, and the site visit. Lots of students were trained. Actually, over 190 students were trained through the program. And the technical posters during the Canvia annual meeting, really annual conference, presented a very nice way for the WestNet researchers to talk about their research, to do the outreach in a large-scale event. I think that was also one of the highlights of the WestNet mandate. Quickly, I'd like to summarize what I observe out of WestNet. I'll leave some time for your questions and discussions. The network programs, I believe, delivered what it intended to deliver, to really fit into the programs of NSERC, which involves people, innovation, discovery, and partnerships. So we delivered the research programs leading to new technologies, new discoveries, and dissemination through their publications. And the network trained over 190 PhDs, masters, and undergraduate students. And WestNet built a strong collaboration, particularly among the research community within Canada, focusing on the wind technologies. However, there are some I think deficiencies of the network program, particularly WestNet, I can see. One is that the research programs, as defined by the program itself, were not agile enough to adapt the changes in the technology landscape and in the wind energy sector. One of the examples might be that during the evolvement, the interconnection requirements, particularly when you increase the level of penetration, were changed, were evolved. New technologies would need to be looked at. However, once we defined the research program in 2006, we won't be able to adapt to the new landscape of 2010, for example. And the other is that we at the beginning of the process, there were a lot of interest, many researchers. As a result, when we developed the program, we tried to involve as many researchers as possible. As a result, we have 17 projects and over 30 sub-projects. As a result, the resources were split too thin, and we I think that had some impact to look after the innovation chain in the latter stage, such as the demonstration and commercialization and integration, adaptation. That was not a strong point. I hope in the future this could be addressed at the network level. The other observation I had is that there was a lack of connection between the network with the wind developer and the wind farm operator. As a result, I think impact of the developed technologies will found a hard time to evolve into the marketplace. So these were observations. Just a quick wrap up. It was an exciting time. That was 15 years ago to start with. Very nice to work with all the researchers. We can Nerdica and now can Canvia. Again, this is what it is now, quite a few years after the completion of WestNet, and very nice to see the wind energy research network is coming to its play again in the national scene. Now, I think I'm going to stop here, and if there are questions or discussions, comments, I'd be more than happy to hear. Marianne, back to you.
Thank you so much, Lucien. That was great. What a great summary of what was really a very successful collaboration. And you can definitely see the results. It definitely advanced wind energy in Canada. Does anybody have any questions for Lucien? If you do, oh.
I think Jen
Hiscock, go ahead.
Thanks, Lucien. That was awesome. Actually, I really appreciate you doing that, because I was not I was aware of WestNet, but I wasn't so involved. So this is really helpful. On your comment here about research programs not sufficiently adaptive to the changing industry, this is something I've thought about a little bit. Was that related to you got WestNet for 5 years, or like the
yes, it was a 5-year program, but the research programs were defined actually a couple of years ahead of time.
Yeah.
And we extended that for 1 year. So it's a 6-year research program, plus the development. You're talking about it's an 8-year time span, relatively static.
Yeah, and so do you feel like some of that was linked to the fact that you have to, ahead of time, say, like outline your entire work plan, and you were sort of stuck on the accountability to how you were originally going to spend your funds, and you couldn't pivot? Like, how much of this is avoidable, do you think, in the way that you set research goals and that type of thing, or how much of it is just to the way you get money?
Sure, Jen, it's a very nice comment. Right to the point. I guess that was one of the deficiencies of the program itself. We got to define the research projects at the beginning when we send the applications, and there is no mechanism to change it. Hopefully in the future programs, I wish the funding programs would have some mechanism to do some evaluation along the line. Without changing the budget, you can change the scope to adapt to the marketplace. That will be a big plus to my mind.
Thank you.
Thanks, Jen. Are there any other questions?
Marianne, I have one question.
Sure.
One quick question, and is following up with the question that was made by Jen and Professor Cheng's presentation. How can we, ahead of time, from the beginning, make sure that these the researchers and those that are mostly working in the labs and on simulation and small-scale prototypes, this will end up with involvement with actual industry. I know that this is the shortcoming with many of the things that we do at the university and at universities, and after so many years, let's say 5 years, 4 years of the program, which has too many players, everybody goes back to what they were doing before, and then this link is lost. Even between the researchers, sometimes is lost. How can we make sure that from the beginning we set up some mechanism to make sure this will remain in place?
I think that will be a bigger question for Jen and Marianne, looking into the future, particularly in the designing of research programs. I guess I know what should I do from the researcher's viewpoint. I think I'll kick the ball back to Jen and Marianne. If you can comment on that, that would be appreciated. You're muted, Jen.
Realize, yeah, like it feels administrative, and so those types of tasks don't feel valuable when there's only so many hours in the day, so many dollars in your insert grants. You feel like you have to really dedicate it to publications and real work. But there's somebody who's got to go around and pull people together and make sure that, you know, there's cross-pollination between researchers, help connect the dots by recognizing like opportunities to bring learnings from one area and apply them to another. Like it really does merit dedicated attention just to those types of activities. So it'd be interesting to hear about the WECAN work plan or roles and responsibilities around that are envisioned, because yeah, it's something that we face all the time. And on the program side, I know that there's it's hard for us to justify those kinds of resources. Like when I look at CanMet Energy, we struggle to be able to dedicate a lot of dollars for CanMet to provide that sort of connecting the dots role, because there's pressure on them as well to have like their own research outputs. So it's something that we're aware of at the program level, and I understand how much value it has and how much the industry struggles to put the resources behind that type of effort, given the constraints and the pressures that you're all faced with as well. So anyway, I'd be interested to learn more, Ryan and Marianne, as you guys are aware of this, but I'm sure it's something that you've been talking about.
Thanks, Jen. I can just pop in quickly just to build on top of that. But I completely agree. So, you know, at the CanMet level, like in many of your own labs and institutes, you know, there's a limited amount of resources and time and available funding, and so you want to make sure that what you're engaged in has real impact. And that's certainly one of the big factors for us in helping to establish this research network, is to really understand and hear directly from industry, from utilities, from people working in the field, what the current gaps are that they could see could have value for applied targeted R&D, and then to make those linkages with universities and research institutes who have in those areas. So it's absolutely something that we'll be planning to focus on throughout the sessions over the next few weeks. And certainly we want to hear more ideas from everyone about how to be successful with that topic. And then you know, we'll, as a steering committee, we can take back the feedback that we get over the next few weeks and maybe make a proposal and we're open to different directions about how this could go. And the more we hear from people with experience in these areas, I think the more successful we'll be overall.
Thank you.
I like the comment. Yeah, for sure. And I also know, I think Phil is still on the line from CanRIA, but I think you've got a lot of the right people in the room here to help stitch this together.
Yes, thank you everybody for your comments and current I'll just note that Curran Crawford mentioned Look to Horizons 2020 projects, and then, as Jen mentioned, use the students. Those are great ideas. And like Ryan said, this is definitely something that's on our radar and is very important to us. And we will be looking for input. But kind of along these lines of research and industry collaboration, that brings us nicely to our next speaker, Phil McKay. So Phil, okay, yes, thank you for sharing your screen, and thank you. He's gonna give us more of an industry perspective of research in wind energy. And again, if you have any questions, you can ask them after the presentation or enter them into the chat. Thank you, Phil.
Great, thank you very much. This is a very exciting conversation for me to be a part of, and I just want to say up front that at CanRIA we are really interested in being part of this discussion going forward, and hopefully we can bridge some of that industry research gap. As mentioned, my name is Phil McKay. I'm Senior Director of Operations at the Canadian Renewable Energy Association. I'm going to run through a little bit of our work that we've done over the past little while, including some stuff from last year with CanWEA before we merged. So if you don't know who we are the industry association, the National Association for Wind, Solar, and Energy Storage in Canada. And this is a mashup of the Wind Energy Association and the Solar Industries Association that came together July of last year. We do have a staff of about, I think, 14 people at this point working across the country. So we have somebody in Calgary, in Montreal, in Toronto, and as well as our Ottawa office, and then myself down in the sunny south here in Windsor. So I'm going to run through just quickly in respect of time here, because I really want to have some discussion, if we can, at the end, hear what you think about these ideas that we've uncovered. We did an optimization guideline project last year. We launched it in October. This was a members resource. Nergica helped us out in a big way with this one. And so I want to share it with you as well. It is an in-house resource that we use for our members, but I want to share with you some of the findings that we have, as well as what we've done since the guideline came out to see if we could prioritize some of this work. So here's an idea of the table of contents. So the idea was to say, okay, what actually are the optimization opportunities that we have in the wind energy space? And keep in mind, this is large scale wind. So we're talking commercial scale megawatt type turbines aggregated into sites. So what are our actual opportunities? You can see how we broke it down here. And in the brackets, you'll see a number, and that's sort of the number of opportunities we identified. Certainly not completely covering everything, but we think it's actually a decent overview of most of what's out there. The first section is increasing power output. So if you can think of generating additional megawatts every year. So you bought a turbine and it's rated for a certain amount of power. That's what you expect. Can you get more out of it? The next one was improving efficiency. So not necessarily pushing the bar on overachieving, but how do you just cut out some of the extras and be super efficient on your site? You can see a number of categories that we break it down under there. Then we did restoring performance. As we know, these things are degrading over time, as any machine will. And then finally, life extension, which is, I think, going to be a very big piece of what we talk about in the coming days. As a piece of context for why we were doing this is that last section there, overcoming barriers. So within each of these headings, we had a set of barriers that we identified to deploying that optimization. And while we did look at existing optimizations, things we know about like vortex generators, we did also look at things that are emerging as well, passive and active microtabs as an example. So it's kind of a combination there. We have these summary tables within each section that says, okay, here's the optimization, but then here's the list of barriers that might be in our way to deploying these. And you can see some of the obvious ones like regulations, PPAs, and how you deploy this on a large scale. So the typical kind of growing pains of any new technology. So hopefully this gives you a decent idea of what was in the what's in the report. I won't spend too much time there, but happy to answer more questions after this if you'd like. What I want to talk about is what we did next with that, which was to try to prioritize what was in that document. Okay, there's too much here. We can't really tackle it all. What is it that we might actually want to prioritize if we were to maybe reach out to a research network or something like that? And so ran a survey through the Operations Caucus, which is a group that we have at CanRIA. It's about 30 companies who work in operations and maintenance specifically. And we got 12 responses, all from wind farm owner operators. We did have one other independent consultant in there. So as I'm going through these priorities, keep in mind that this is a very specific subset of the industry. So these are the folks who are who own and operate these sites. They are the ones with boots on the ground. They from my experience are very practical people, and they see the big picture without getting lost in the kind of longer term overall portfolio business strategy. They are really careful about their sites and making sure that they're making money, to be honest. You can see how I've organized the next few slides, and hopefully you can keep up because I want to move through these quickly. There's the category and the subcategory, and then priority 1, 2, 3. We decided we'd pick the top 3 that were prioritized, and then I've listed out a few others that were also there but were ranked a little bit lower. So if we take the first category, increasing power output, this was that kind of power boost category. That first subcategory is hardware. This was actually, to be honest, quite interesting for me. I didn't think that repowering would score so high on the list here, especially since Canada's fleet is really in that 7 to 10-year-old time frame, with 20 years being the objective and 25 being quite reasonable for what we've got installed. So there was a lot of attention placed on that for R&D. Please look at this, is what I'm hearing. There were other things out there that were much more specific, some of those aerodynamic improvements that I said before. VG's certainly on the list, but it was that big picture site-wide activity that kind of hit the top of the deck. In that same category of increased power output, we looked at software specifically, knowing that hardware and software can imply very different capital investments. So what was on the software top list were turbine control parameter tuning, site-wide level controls, control upgrades. And just to give you that example again, there were some very specific things in there like nacelle transfer function correction. So what I'm kind of starting to hint at here is that we know of a number of great things that we can do. We can hire a consultant to come in, take a look at some of the alignment, transfer functions, that kind of thing, and error in there. But what's emerging is larger site-wide controls. How do we control these machines better? How do we eke just another 0.5% out of the farm over the course of the year? That kind of thing. So it is a trend, but I'll get into that a little bit more a little bit later. The second category was improving efficiency. So the first category here, site-wide processes or modifications. Not surprising, again, you've got kind of that holistic picture. We want to talk about reactive, predictive, planned and preventative maintenance, machine learning for condition monitoring, starting to get into some of the more specific issues like ice and extreme weather, but not as keen on things like upgrades to replacement parts, which would be where you kind of run as well. So keep that one in the back of your mind. under this one as well, we had workforce efficiency, and these ones don't have top 3 rankings. There just weren't that many optimizations to pick from. So if I listed all 3, I'd be listing the least favored as well. But under workforce efficiency, troubleshooting efficiency was #1, and actually by a bit of a long shot. So this is that pain point when somebody's trying to diagnose what is wrong with the turbine and they can't quite get to the bottom of the answer. It could be somebody who has a ton of expertise in this area, but it's a problem they've never encountered before, or it's strangely unique to that make and model, or whatever it is, or maybe a mouse made its way up through 300 feet and they hadn't actually accounted for that. So just stuff like that where they're stretched and you've got days of downtime because of troubleshooting alone. On that second piece there, workforce or work planning, fault reduction programs. So you see kind of the connection here. This is when a turbine sends a fault code and it didn't need to, right? Everything is actually, it's managing fine, but just because of that specific site or that specific turbine, the operator discovers that, yes, it's actually okay, but now I just lost a day trying to identify that, yes, that was okay. So reducing those kind of faults. Under restoring performance, no subcategories here. This was just one group. But you see blades, blades, and blades. So this is what we know and have come to learn. This is, I think, one of those adaptability pieces that Dr. Chang was talking about. Didn't necessarily know this up front, that blades were going to be this big of a challenge, but when we're talking about restoring performance, they are what comes to mind first for operators. Condition monitoring systems does show up there again, and that's, I think, important to note. This is last one, I think, life extension. Again, no subcategories. When we got the ranking in on this, this is where condition monitoring really came to the forefront, because it's tying into all these other things that we want to do. So it's the eyes for the action. You've got design upgrades there as well, and mechanical load management. So if you can picture the life extension optimizations that we're looking at here, these are the things that are going to allow those turbines to run as long as possible. And the way to do that is just to lessen the stress on the machine. So you got to see the stress on the machine, and then you got to lessen their stress on the machine. It's not a breakthrough concept by any means. We've been doing this for hundreds of years, is finding our stress points and reducing them. But what's happening here is we're dealing with this on a system-wide basis, not a component by component basis, right? You've got an integrated drivetrain from blade tip right down tower, and that whole system needs consideration and condition monitoring. Okay, so the last couple slides that I have here are my opinion. These are my observations, and so as being among friends here and other researchers, I'll say that I'm stepping kind of a little bit outside of what might be a safe industry assumption, but I don't think I'm too far off here. So I've been kind of saying this along the way, that what we're talking about as far as R&D and getting better at wind energy in Canada is about systems. It's about trying to improve on what we already have, what we already know. We've been running these machines for years now. We know how they break for the most part. There's still some mysteries on the horizon that we haven't gotten to yet, but the optimizations and what system operators are turning their attention to are the system-wide issues. And so if we're going to focus on R&D, this seems like a great place to start. And I will say that I'm glad, Jen, you mentioned the pathways, because it's not clear, right? These are not well-defined pathways that have been done elsewhere. The whole powertrain is unique. And so this is, I think, going to be a stumbling block for us, is because it's so big. It's so wide and all-encompassing that you need to be able to be in the space learning alongside the operators. but the operators aren't necessarily just going to open up all of their books to just anybody. There's been an overwhelming number of sales calls about, we've got the solution, right? Here's the system that's going to do it. This is the condition monitoring system that you need. And they're starting not to pick up the phone anymore. There's got to be more to it. There's a next level here of integration with a smart way of operating these assets without kind of all the bells and whistles that aren't necessarily needed. So I'll stop there. I could talk about this all day, and I want to, but I think I'm out of time. So I'm going to leave it at that, and happy to talk further offline if you want to reach me here at my email address or online. That's my spiel. Thanks, Marianne.
Thank you so much, Phil. That was great. What great insight you provided. Does anybody have any questions for Phil? We have a couple minutes.
I do. This is Claudio. Claudio Canizales from University of Guadalupe.
Go ahead.
Interesting presentation, Phil. I guess this is the perspective of the industry within the context of Canada. I guess we don't have manufacturers, so we have wind operators, and I guess that's where the needs are focused on, and I guess makes perfect sense. Seems like asset management is the main concern, isn't it?
Yeah, I think you're putting your finger on it, right? That we're not we are not designing and manufacturing new large-scale megawatt turbines in Canada at this point. There is some feedback from the OEMs who operate here that goes back to Denmark or Germany or China, but it is a lot about the operations of these assets. You're absolutely correct.
And then you made a comment at the end that there are products that are being sold in terms of monitoring, right?
Yes, yeah. I mean, there's a wealth of condition monitoring equipment out there, and different approaches to whether it's oil sampling or vibration or acoustic or all of this kind of thing. And so it can become overwhelming for an operator to know what's going to actually answer their questions. Okay,
so there's a lot of these products being built here in Canada. They are being basically offered to these wind operators, correct? Did I understand that correctly, or this is?
Yeah, I wouldn't put the boundaries on Canadian made. I think we're talking international companies that are working around the globe offering these systems on a large scale. But I guess to answer your question as best I can, commercialized software, commercialized systems. Yeah.
Okay, so from a point of view of R&D, is mostly about, I mean, from what I got from your presentation, it's asset management, right? Focusing on that kind of stuff.
What comes off the back of that condition monitoring system and how you make a decision based on that data. Because it's not clear all the time. As we mentioned, there can be some false alarms, right? Is that a valid, do I spend the next week chasing that false alarm, or how do I make a better decision based on better data?
Okay, thank you.
Thanks, Phil and Claudio. Maybe just one more quick question if anyone has one.
This is Mehdad Kazarani from Waterloo, and I have one quick question that might be because of my lack of understanding. Phil, you talked about repowering, partial repowering. I have trouble understanding what repowering means.
Sure. Yeah, so we see a lot of this that came out of the U.S. after the production tax credit started winding down, and turbines were being partially or fully repowered. So that means a replacement of anything from the nacelle to the blades, the generator, the motor, large component exchanges to a different design than original stock. Yeah.
Okay, perfect. Thank you very much.
Okay, thank you, everybody. I think we're at our time. Thank you to all the speakers today. I think it was great. It exceeded my expectations, and I look forward to the upcoming webinars. So, as a reminder, we'll hopefully see a lot of you here Wednesday at 1:30 Atlantic time for IEA wind tasks, wind turbine LES, wind turbine aerodynamics, and wind farm modeling. And thank you to all of you for coming today. This has been a great kickoff meeting, and see you soon. Bye.
Thank you.
Yeah, thanks so much. Bye.
Thank
Bye.
you.
Marianne and everyone.
Bye now.
Thanks,
Thank
everybody.
you. Bye.
That's great.
Bye.